Hi there guys, my name is Maitri Patel and I'm back with the video. So today I'm gonna do like assignment 1 from the applied machine learning. So let's get started. So in this we have to like work with fashion MNIST. So we have 60,000 images and have to predict like the image by one algorithm. So for that, the first question goes as what are the dimensions of train images, labels, and test images and labels? So for that over here, I've imported Fashion MNIST and from Keras datasets over here as you can see, and then we have to load things over here as you can see, and after that we have to show the shape of train images, train labels, test images and test labels, which we have shown it over here clearly. So moving on to the second question. The second question says that what are the lengths of train labels and test labels? So for that I have used the length function for it. So we can say that the train labels is 60,000 and the test labels are 10,000. The third question is please show sum of train and test labels. So we have to write the train label and it would give us the whole array over here. The same goes for the test labels. We have to write for it and then like it shows us the whole array for it as you can see over here. Moving on to the fourth question. So it says please show the digital content of image index in the training dataset. So loading the training dataset, it would give us over here, it would give us the digital content. So for it, it's all pixel over here as you can see. Just a moment. It's all pixel over here, so it's 28 by 20, so it is 28 numbers in one array, and as such there are like 28 arrays over here. So moving on to the fifth question, it says please plot the image of the index phi in the training dataset. So for that we have to import the matplotlib over here from as a form as a plt over here, and this function right over here, the plt and show train images, it would show us the image that you can see. That function would show us the image over here. Moving on to the sixth question, it says what is the label for the index phi in the train label, and looking up in the about list, what does it mean? So for that, train label over here, so it gives us label 2. So label 2, it simply means it's a trouser. That's all it means. As you can see, as it's asked in the question, we would get the output of label 2 and it means it's a trouser. Moving on to the seventh question, it says please show the digital content of image index 500 in testing dataset. So it's same like number 4 which we did up there, and we are showing the digital content for 500 over here as you can see. Moving on to the eighth question, it says please plot the image of the index 500 in the testing data set. So for that, now we don't need to import the plt as we have already did that in number 6. Let me just show you. Yeah, it's on number 5. It's over here. We have already imported it plt, so we don't need to do it again. So I just have written the plt so it can like show us the image. Just written the function so it shows the image for the 500 one. So moving on to the ninth question, it says what is the label for the index 500 in the test label, and looking up in the about list, what does it mean? So it's the same for the test labels. It's label 2 and it means it's a trouser as you can see. Moving on to the 10th question, it says please import models and layers from the Keras library. So over here I imported models and layers from the Keras library as you can see. By this function, the models in layer will be inputted. For the 11th question, it says define a sequential model and call it my network. So for that, I've defined a sequential. For that, I put the sequential method over here and defined it as my network as written in the question. Moving on to the 12th question, it says reshape the images from 28 to 28 to one column with 784 neurons, and it also says use two methods, one from the book and one from the video. So for that, I have this one over here, it's the book method, and this one is the video method as it's written in the question. I've shown it over here. So after that, we have to find the dimension of train image. So it's 60,000 28 by 28 up there. So now we have it as like 60,784. So now it's just one array and 784 elements in it, as you can see it over here. Moving on to the 13th question, it says just a moment. Yeah, it says also please normalize the image by dividing the image by 255. We have to use for also this one, we have to use the same. We have to use one book method and one with the video method. So for that, I've written one of the book methods over here and one of the video methods as per asked, and for that it's over here, it's the same as the 60,784. Then the train image, that so this is the dimension of the train image, and when we output that over here, as you can see here. So yeah, when we output that, it's divided by 25, so it's giving us all the results for which is divided by 255 over here, as you can see. Okay, so moving on to the 14th question, it says add one hidden layer that has 512 neurons using ReLU action function. So the name my network, I've used it over here, it's a dot add layers, and then so over here the 512 that I've used, it's like neuron and activation reload. And I also did input shape 28 into 28 over here, as you can see. Moving on to the 15th question, it says add another hidden layer that has 128 neurons using reload action function. Activation function. So for the 128 neurons, I've added that two over here. It's as in the upper one, it was said 512, so I've used it over here, but for this one it's saying 128, so I've used that over here for the activation and reload function of the neurons. Moving on to the 16th question, it says add the last layer as the 10 neuron dense layer that uses the softmax as the activation function, and why we use softmax for the last layer, and how does it work under the hood. So for that, I have added activation software over here, which is 10, as you can see. So clearly it's softmax is mostly used in classification, machine learning and algorithm, and software converts raw values as outcomes or functions, and so they all converted into probabilities. That's what it means. So for the 17th question, it says use the following two settings for the compiler and run them separately and see what the differences are. So over here I did that too. So it's been said if you can do both of it, but for this one over here, it's for the it's the same, mostly it's the same, but for this one it's the loss is categorical cross entropy, but for this my network compile, it's the loss is sparse categorical cross entropy. and accuracy rate will be same. So moving on to the 18th question, it says now after for this we can use any of these functions. So for that I have used the first one over here. So as the 18th question says, like after the compilation we have to like try to find the pattern using the fit command, and the epochs need to be 10 for this example. So for that over here, like the epochs, it needs to be 10. So I've written here our epochs is equal to 10. So when we run the command, it gives us like, let me just show it to you over here. So when we run the command, it gives us accuracy and loss over here. As you can see, this is like the accuracy and this is like the loss. So with the epochs 10, one after the another, we are getting better accuracy, as you can see over here. But it's the opposite for the loss. For loss, it's getting lower. As you go from one to another, it gets lower. Moving on to the 19th question, and 19th question says, how do you compare the fashion amnes with what we learned in the class using the amnes, and what can we infer from the differences in the accuracy, and what could be the reasons for that? So for fashion amnes and amnest, I think that both are like the same process. It's just an amnest we are predicting number, and in this shoes are doing with clothes. So but it's noticeable that accuracy in amnest is almost like 99%, but for this one, as you can see it over here, it's 91%. So the prediction in clothes is harder than the prediction in numbers. That's what is my view towards it. And moving on to the 20th question, it says use the evaluate to calculate the achieved accuracy and loss over the test images and label, and do we have overfitting? So for that we have to reshape test images and divide it over by 255, and after the calculation we got the accuracy. It's over here, it's 0.8852, and the loss is 0.3395, as we can see, and it's not the like highest accuracy that in those hypotheses we have done in the above work, but still so for that it's written over here, so we have printed that, so we get the test accuracy which is written over here, it's 0.885, and the loss which is over here, which is 0.3394 something. So it's been shown down over here, we have printed that. So it's basically it's not the highest accuracy which is shown in the above work, but it's still a good accuracy which I will see. And that's all for the assignment 1 for today, and hope you liked hearing it, and thank you so much, and see you next time for the next assignment. Till then, have a very good day, and we'll see you soon. Bye bye.